Hey, and welcome to another part in how to start with Monogame. Today we're going to talk about refactoring. Not Monogame specific, so we're going to apply it to this project in slight fashions, and we'll see how much we get done. It might be a pretty short video, but I feel like if there's something I've learned through my professional life as a programmer is that refactoring is a thing that I used to keep away from when I was kind of doing my hobby things. I usually made a project and found it to become all this, a spaghetti mess, and I just abandoned it. I kind of just crumpled it together, as a piece of paper, just threw it. And then I started anew and felt like, oh, this is so nice. Like everything is clean again and I can work with this. And that is why I think one core thing in your project should always be to think about refactoring and not to push it too much into the future, and actually do your refactoring not, of course, at the same time as you're programming, because sometimes you just need to get something done. And that's what we've done in this project a bit. And I feel right now like, there are some things I want to refactor. So, for instance, I come back to this project and look like, in the Sprite, I added this is player controlled, and we use it to check if the if this sprite is player controlled, do this and do that based on what you have pressed. And you know what, the problem with this, and I'm not sure if I took it up while I coded that segment, but I'm kind of putting player control actions into a class that is basically holding sprite information, like just basically texture and position. Kind of, to me at least, it feels kind of weird to make that player controllable. If we made something called like an entity, and perhaps there we could say is player controlled, then use up, down, left, right to control, and if it's not player controlled, use some sort of AI to move it around. Not sure that's the approach I want either, but so the first thing I want to do is just to change that. We'll remove it, but we'll keep this update code. We don't need to set is player controlled here, and we do not need to have this parameter. And then we'll go to the startup game screen, and it does not take the is player control parameter. However, it's the tiny male sprite that is the one that we control. So for now, since we have just moved this and we haven't found like the perfect solution yet to this, we're going to just kind of go here and we'll say before we update this. And now I have to remember here, but we'll look at the tiny male sprite. And I forget if I'm allowed to just change the position in this version. We'll see. We'll do position Y. And apply the math to that. And we cannot. And that's because of this, that we kind of made it into a, I don't want to say wrong now. I believe this is called a field. I always get fields and properties mixed up. Or is this a property? You know what? It doesn't matter. What it is, at least, is it has a getter or a setter. I have to set the entire struct in order to be able to do this. So you would have to like extract this tiny male position to its own vector and say vector.y, and then say tiny male sprite dot position equals this vector. Oh yeah, except we do not have a setter for it, so I would have to say set and it's position equals value. So we can now set position like this as well. But I don't really like the way you do this. This is also, you know, we're refactoring. I might as well like that. I guess that is also kind of true for refactoring. You want to be sure that you want this change when you're refactoring. Of course, refactoring should make everything better. Sometimes you just have to move a few things and that's fine. But today we're trying to get this to work a bit better. So the way I usually do it, so I'll work on that principle, is whenever I don't want, sorry, we're going to the sprite class. Whenever I want to change the position of a sprite, I don't want anyone to easily change the position by just setting this. What I usually want is some method where I can say set position, and we'll either take a full vector, or we'll do set position and say float. Oops, got a bit of Swedish letter in there. And we'll say position equals p position and position, oops, new vector pxpy. Now this doesn't really solve the entire thing here, but sort of. So what we'll do is we'll tell this sprite to set position, and we'll say x and we'll say y minus this. Okay, so this way I can utilize the x position that isn't changing, because we just actually want to set one of the positions, and I do not have any method of doing that. Like, we don't have a method of doing that right now, so we'll just set the position like this. So we'll just have to do this for this one. This one just increases y, so we'll just add a plus sign, because that's the only difference. And then we do the same for x. That means we have to switch around. So we'll say position x, and this is the subtract, and add the position y to the end. That doesn't change when you go left and right. And we'll do this, and we have to add because we're going to the right. So for now, this is actually not the end of how I want this to look, but it's the current, more correct version, which is we don't have entities, we have sprites. So we are controlling the sprite position in the update of the actual game screen, where the actual game is currently going on. Let's run this, make sure it all seems to work. I might have forgotten, something. Yeah, we have one more is player controlled in the constructor. Oh yeah, okay, it was framed sprite is player controlled as well. It had to have that as well because sprite did. Okay, we go back here. See if we can launch this. And we can move. Okay, so everything here is quite tiny. That's the next thing I want to change. I believe so. Yeah, we want to add scale to the fonts when we draw them. So first off, I've forgotten a bit of code here, but we can look at this instead. This is not how it's going to look. This is just I made a temporary method here. So we want to add scale. Actually, it's probably better if we just do this. We'll delete this. Sorry about that. That was me kind of typing out what we're supposed to do here. But I wasn't really finished with it and had forgotten about it. Okay, so we want to add scale to a draw string because we want to draw the font larger because it's very small right now. So we firstly add a scale parameter, but it's usually 1f, which is 100% because it's you can say 123% like this. Some might ask or something, why don't you do like an integer scale? And you could say 100% like this, but then you can't say 100 and 0.5, etc. But with scales, and usually scales work like this, you can say, you know, very accurately exactly what scale you want. But yeah, so when we draw the string, we'll say what scale we want, and we want to apply it to the drawing of the sprite. Every letter needs to be, you know, scaled up. So sprite draw needs to take scale. So we'll go, I pressed F12 now to go to the override here in the framed sprite as well. It's going to need to take scale. Just checking here, I most likely want this one as well to take scale. And I think we'll say that default is always 1 for every instance. Drawing, this is the sprite, I believe, is it? No, it's calling this one, but yeah, p scale. So it calls this one, and this one calls the actual drawing of a framed sprite. So it has this source rectangle, and if we look through the different overloads, we eventually get one that has scale in the as a float. So we have to follow this one, and we'll see. We have texture, we have a position, we have a source rectangle, we have a color. So we need to add rotation, origin. So rotation, we just basically add 1f. Doesn't give it any kind of rotation. Rotation is, or actually it might be 0 when I think about it. You know what, we'll try with 0. I think it's 0 because the rotation, I believe, is in either radians or degrees. I think it's radians, which means it's like 0 to pi or 0 to half a pi. I forget, or twice, double the pi. It's a lot of pi. We'll just skip that one. We don't need rotation right now. Origin, we can give a vector 0. So the origin is where in the texture the origin is. So if you calculate its position and say, I want to draw it here, and if the origin of the texture is in the middle, like in the absolute center of the texture, it'll try to place the center where your position is. But usually we want to draw it at its top left. Let's see, top left this way. So like this corner of my webcam image. That's where we want to kind of base our textures on. So we're not changing anything. We're just basically telling it the same thing. Okay, and then there's scale. We'll say p scale. And we can say sprite effects, none. It's only if you want to flip it, as you can see, flip horizontal, flip vertical. And layer depth, I actually forget if the if it's 0 or 1 is the usual. But we're drawing every sprite in, on this layer, so we'll say 1. I think it's kind of okay to put it like one step above other things, if there are any. I have made a boo-boo somewhere. Oh yeah, this is overriding sprite, but it's not suitable anymore because there's I've added an extra parameter. So we'll go to the sprite class and press F12, and somewhere here we have a draw function. Here it needs to now take a scale, which means this has to now use scale. And let's look here. This one allows us to say null for a lot of things. Let's see, we have texture, we have position, destination, rectangle. We'll just say null. Source rectangle, null. It'll probably take the entire texture in that case. Origin, we can say null, that's fine. Oh, rotation is actually 0 by default, so we had that correct. We can say no, and here's scale. Scale, and then there's, oh, I had tint here. It asks for color later here. Let me get back to, so we have texture, position, and then for destination rectangle we say null, for source rectangle we say null, for origin we say null, rotation we say 0, and for scale we say, oh, did I, yeah, scale, and then we need color, which is tint, and then we don't have to add these. Now I just wanted to, oh, have I done something wrong? Let's see. Oh, it gets confused if I don't, I think. So, oh, and 0. Actually, we can say sprite effects none. Let's see if I've done stuff correctly now. Kind of convert to vector 2. I've missed something then. Texture, position, destination, source, origin. Oh, it wants a vector 2. Ah, okay. So that's fine. We can do this. So basically it's because you can scale it in both horizontal and vertical if you use the vector. We want to uniformly scale it, so that's fine. If we want to kind of later in some form or fashion just stretch it in the horizontal or vertical, we can change that and make that possible. Maybe for some effects you would want that, but currently not so interested in it. A uniform scale is pretty much what I desire. So finally coming back to this, okay, so we have scaled up the actual drawing of a font or for each letter, but right now they're being spaced according to the frame size width and the spacing. So we need to just scale that up as well. And I pressed the wrong button. And just for readability, I'm going to do this. And it wants this to be an integer. And I'm pretty sure we'll be fine just kind of flooring it or whatever a normal, I mean it's rounding it. I actually haven't tested out, or I have, but I've forgotten if it rounds up or down. I'm not too bothered. If I notice some kind of artifact from it, we'll definitely change that. So let's now try to draw this in a new scale. Let me just find my startup game screen. So somewhere here we say hello world, etc. Let's also break this up a bit so it's a bit easier to perhaps see. Let's see. So here we can say scale 2, and let's hope it works. And as you can see, it's now larger. If I make it a bit of a shorter text instead, since I made it very long because I wanted it to really show on the screen when it was small. But let's make it just hello world and make it 4 times the normal size. Let's even hot it up to 8. Also, this small font, I do say it's red, but let's go with something else like powder blue. Okay, so now we have text that is scalable. It's a bit better. So let's see, we're on 18 minutes in about-ish. I have one more thing I would like to do, but I need to think before this one, so I'll be right back. Okay, so we're back. As you might have noticed on my webcam, it's a bit later in the afternoon here, or it's at least a bit later, like 2-3 hours. I was kind of starting to code something, and I noticed a bit of a weird kind of memory thing going on in the diagnostics part, and one thing led to another. I sat for a while and started looking through. I've coded a lot of things, and then I've tried to kind of clean it up a bit. So if I launch this currently, whoop, we have to still do one thing, and that is to undo this. Okay, sorry. Let's run this again. Okay, so I've changed where the text goes. It's just put up to top left here. Not much difference there, and I've increased the speed at which this character moves, just to kind of make things a bit clearer. Also, something I've been meaning to do that we can do now is when we're drawing him, should be able to say 4 times scale. Okay, so now he should be a bit easier to see. Okay, good. Now I've already coded a bit and then like taken a bit of a reverse clock, like reverse time a bit, and undone everything. So I'm going to look at my notes because I've already written all these things, and I'm going to try to do it in a manner that makes most sense. But this input manager was faulty because it's if I press right and then down, nothing happens, and then yeah, it kind of gets stuck and stuff. The way you have to fix that is literally to go into the startup game screen here and say if input and like well, input up and input right is held, then do diagonal movement. We don't want to do this. This is I kind of, I don't know. I probably made it because I didn't want to start with the advanced version, so to speak. But we're going to go the advanced version today. So first off, we just delete that pressed thing and we clear the update. And we don't longer need any player input, or rather the variable where we saved what you are currently pressing. We don't longer need this input up, left, down, right, back to be a flag. We'll just have up, oops, up, left. Oh, I shouldn't remove the this. We'll still have an enum called up, left, down, right, back. That's the different inputs we can create. So what I want now is a private dictionary of input, and I want something called input data. So for every input, up, down, left, right, back, we want an individual information. Not an individual information, but individual information. We'll call this the state. So this input data needs to exist, so we need to create it. So add class input data. We'll make it a public class, and let's see here. First of all, we want a bool called isPressed. We want one called isHeld. So any button can either be pressed, and a press is when you press the button S. But there's also this functionality where you press S and wait a second and, you know, it starts repeating. And isPressed is going to be used as it'll count every instance of S being written here as an own press. That will be one press. However, isHeld is, if I press this button, it's going to say isHeld is true all the way until I release. So we have two kind of two ways that keys can function. Either it's pressed, after a short delay it starts repeating itself with a small delay in between every repeat. And there's one that is just isHeld, like for movement. If you're holding right, you know, the right button, then you'll move as long as it's isHeld. However, isPressed is good for like stuff like menu and whatnot, where you just want to know, oh, is it pressed? And by the way, throw up the menu. We're going to keep track of when the next valid input is. We're going to save it as a double because we can get from the game time, we can get elapsed total milliseconds in a double. And we want to create two constructors. One is going to be the default one. So we're going to say isHeld, oops, false. And next valid input, next valid input is going to be 0. Sort of like saying, you know, anything, because it's going to be, if you have passed this value, it's going to say, yeah, it's time for a new input. So you want it as small as possible. You could basically say min value. Doesn't really matter. It's going to be changed anyway. And the other one, whoops, sorry, I'm getting ahead of myself. It's gonna take a next valid input, because we're gonna say, oh, you pressed the button. Well, I'll add the delay and say, you know, this is the next valid input. So we're going to be using this when the button is pressed. We're gonna use it later. So I'm kind of making it now though. So one constructor is for just create the basically the information, and it's going to be kind of default at false and minimum value. But the other one is, okay, so you've pressed the button, so give me an input data with a next valid input set. I hope it's not too confusing. It'll probably make more sense now when we get to use it. I'm going to want to have two time spans, one for delay and one for repeat. We'll start by instantiating these so I don't forget. So delay will be 500 milliseconds. So it's 0 for, let's say, it's like days, hours, minutes, seconds. But we want 500 milliseconds, about half a second for a delay before the repeat starts happening, which will be 75 milliseconds between every S in this case, or every O, etc. Okay, so time to tackle the big update function. So, like I said, I've already kind of coded this. What we used to have was a list of, we kind of went through the inputs and checked, and all, like we had pressed keys, we asked the state of the input from Monogame, like give me all the pressed keys and like translate them and put them into player input, which was just a number. Now I'm going to paste in a lot of code here, and we're going to go through it. So it's about 20 rows of code, and you can see I need game time for this to work. So I'm just going to fix that at once. We want game time now in our update, and we're going to get an error. So I'm going to go here in the YouTube game where we always call the input manager on every update. It now needs to take this game time, and we have that in our update. So I'm just fixing this ahead of time so I don't forget. Okay, so now we're just, we usually send like in kind of most of these managers, like the sound manager, I guess. Maybe we don't send it to the sound manager, but in all these managers that have an update that requires like things to work, you send the game time. So we do that for input because we're handling time. So first of all, we're going to say, you know, what is the now time? And the now time when this update is happening, we'll look at the game time, the total game time, look at the total milliseconds that have passed since you even started the game. We are going to have a list of what inputs you've pressed. An input is of course up, down, left, right, back. So we're just going to create a list. So if we're using the keyboard, and we're more interested in this, but we also have the gamepad version, but is using keyboard. So here's where we get the pressed keys from the keyboard get state, which you get from Monogame. We look through every pressed key in that list, and if there is a key binding that corresponds to this key, we want to add it to pressed inputs. So we're basically just translating. If you press W, the key W, I'm going to put pressed inputs up here. It's just so we, the next code where we handle this input, it's kind of neutral. It doesn't depend if you used keyboard or a gamepad. It'll translate it into a list of inputs. So we have pressed inputs instead of pressed keys. Here comes the next part. So I'm thinking I'll kind of copy a bit and at a time. So for first of all, we do want to make a for each pressed key in pressed input in pressed inputs. So the list of all the keys that have been pressed this update is now a list of inputs, and we're going to go through every pressed input and handle it. So first of all, we want to catch the data that is associated with this particular input, like up or something, and we're going to check the state. If the state has this key in its different, in its dictionary, it already has some data that we want. So if so, we'll use that data. If it isn't in there, it means we have never pressed it, and then we just create a new input data. And the next available press for it is going to be now plus the delay. So we're going to trigger a press this time around, but we're going to say the next time it's going to trigger a press is after a bit of delay. Okay, and then we check, is it valid? Is this data valid? Because it might come from this one, and we might have previous data that says, oh, by the way, yeah, it's time for this one to be triggered. So we'll check the next valid input. Is it less than what we have now, currently, in total milliseconds? If so, we passed it, which means, yes, it's due for a press. And also, I want to know if this is previously unpressed. And the way we do that is checking data is held, but we reverse it, and that data is not pressed. So it's gonna make sense later in the code here, but if you fetch the state and it's not held, it's not pressed, it's previously unpressed, like it has not yet been pressed, because we're going to reset it to these values that it's not held, not pressed when you release the key. So this is basically telling you this run, like, oh, was it not previously pressed in the previous run? And then we're going to say is pressed is true. Oh, and we can also say data is held. Kind of make a shorthand instead of writing 2 rows of code. But basically we're saying, it's part of pressed inputs, so it's obviously pressed and it is held. However, we're going to add a bit of code here. If previously unpressed, so if you haven't pressed this yet, we want to make sure that the next valid input equals to now plus delay, total milliseconds. So we're literally doing the same as this part. We're giving it the delay, but however, it might have come from this state and wasn't pressed before. So now we have to kind of reinitiate it, sort of like we did here, but if it came from here, we need to make sure that the next valid input is in a bit of a delay. And since we have already set is pressed, is held, these are still true, we want that to, we're not going to change that. However, we come to this part, if is valid. So now we have a state that wasn't previously unpressed, so it was either pressed or is still held or something. So we need to check, is it time to trigger a new press, because we have some next valid input to check. It has been checked here and saved as is valid. So is it time for a new press? If there is, our next valid input, instead of being after the delay, it will now be after repeat. So this is when literally it knows that you're still holding the button, and it says, oh, it's time for another press. Then it adds just a repeat, that shorter timer. I can understand if this is confusing, but hopefully you can watch the code from GitHub, or just pause the screen and kind of think a bit about how it all works. Now, if it's not valid, this is basically, so you fetch it from the state, it has either it is pressed or is held, but it's not time for the next valid input, because it has failed is valid. It's not time yet. So we're going to change is pressed to false. We're going to say, no, it's not pressed. Because literally, I'm going to try to make a bit of a graphic here. Maybe this will kind of make it appear simpler. So this is over time. First you press the button, the delay hits, a longer delay, and then it's going to be press, and then it's going to be a bit of it's not pressed, then it's going to press, it's not pressed, and this time is repeat. But if you check an update, like if you check the state somewhere in between here, we want it to say it's not being pressed. Because if you want to trigger something on press, you want it to have this kind of pattern. While held is going to be like on for the entire duration, right? Every time we check an update, it's going to say, oh yeah, it's being held. And let's say we release it here, it's not going to be held in the future. I hope that explains it a bit better. I always think I'm absolutely horrible at explaining, yet I try to do this, and I don't know, some people say it kind of works, but like I said, leave feedback in the comments if you want me to explain anything. So I also then, after we've done all this, we want to make sure we updated the state here with the new data we have for that input. You could say, well, you already have it here. Yeah, but if you had this version, if it didn't contain the key and you created a new one, we have yet to put it actually in the state. So this kind of keeps it up to date. Let me see. I think it's just one little part left. I'm going to copy paste it in just so I don't have to write it all out. After we've done all the pressed inputs checks, we have this little loop. So we're going to check in the state that we have currently, our own little state here. We're going to go through all the keys that we have, and we're going to check, is it currently in one of the pressed inputs for this update? If it's not here, if it's not contained, we're going to say, actually, there's a shorthand for this that I have yet to create. I'm going to create a shorthand, but we're going to basically set it everything to false and next value input. It's sort of the same thing like this. Input equals a new input data, right? Because a new input data is the same thing. It's just false and a minimum value. We could also do a static input data called unpressed, where we create a property. Oops. Oh, maybe this is better so it's easier to read. Return new input data, and we'll say is held false, is pressed false, and next value input is a double dot min value. And if we back a bit to here, we can instead say input data dot unpressed. Okay, so now we're going to have an error. I'm gonna build just to show the error. Also need to check. Oh, we're up in 20 minutes. Taking a lot longer than I thought it would, even though I know the code. But you can see, even though I copy paste the code, it takes quite a while. So yeah, there's no dot pressed anymore. So what I want to do, and I haven't done it yet, is I want to be able to say, like, I want to just fetch it from the input manager, this input.back, and just get its information, like, hello input manager, I want the information for input.back, and just say is pressed. But you can't at the moment. So we're going to fix that. Let's go to the input manager. And it's quite some easy code. We want to have an input, and we'll call it input. And we'll say if state contains key input, return state input. And if we do not have that, return input data.unpressed. So we're basically asking the input manager, we give it one of the inputs and it'll look through the state, and just if it has a state for it, it'll return it. Else it'll just say, you know, this button isn't pressed. You're asking for a button I don't know about that has not been pressed. And as you can see, this works now. So we're going to remake this one as well. So we'll say input up, and now you can see that you get the is held is pressed. Now for movement, is held is way better than like a one-off. And I'm going to show you kind of what is pressed is going to be used for. This is down and this is left. So I'm just kind of copy pasting and changing these to the correct versions. Okay, let's just see if this works now. We did something wrong. Let me just check. That should be okay. What have I done? There's probably some error that I haven't had this before. Wait, let me just try that again. Okay, so let's try to see what is saying. Collection was modified. Oh, that is true. So, it's kind of interesting. I think I'm allowed. Okay, so I can't do it this way because I'm basically saying I want a new object in here. So we can't do that thing there. We'll have to say is held is equal to is pressed. Oh, come on. Is pressed is false and next valid input equals 0. I thought I could minimize this one, or we could do double min value. But I think that's the problem. Like I'm trying to insert a new object in there, and I'm not allowed to while I'm going through. But as you can see, now we have smooth movement, and I can move diagonally pretty easily because, yeah, if I'm pressing up and I'm pressing right, then you know it works. I'll try to be quick here, and I press escape, and it just takes me out. Now, what if we did is pressed instead on the right? If we press right now, it's going to simulate almost like if you pressed a button. So you can see if I press right, he moves, it takes a while, and then it repeats right. And it's even easier to... Actually, I think I still have a bit of a problem that I've introduced in my code. Let me just get back so I can fix this a bit quick, because time is running out. Okay, I sort of found my error. It was just something I probably didn't notice first time around, and I don't know why I've done it like this. But okay, so when creating a new input data with a new total valid input, sort of, I'm setting these to true, which means this previously unpressed fails the first time around. I've added sounds just to make it clearer. So I play the sound coin when escape is being pressed, or every time right is being pressed. So if I press escape the first time around here, you won't hear a sound and the game won't quit, and then I press again and it does it. And that's just because the first time around a button won't work, because this sets the is held is pressed to true, and I check if it's previously unpressed, and it says no, it's not previously unpressed, so it doesn't work. What you have to do is literally just make sure these are always set to false. When you create a new button or a new input data, you'll just say these are false, and later on we'll say they are true anyway. So it only matters for these two lines, and it has to be, if it's newly created, I want this to kind of catch it, that it's newly created, or it's previously created but released. So it should work better now. If I press escape, it should be the coin sound and it should quit at once. Yeah, I don't know if you can hear it actually. I'm trying to click kind of loud. I have red MX keys, cherry MX, so should be audible. I could use my little program that shows my keys as well. And now I'm going to press right, And now you can hear the sound that corresponds to every time it's registering as being pressed. And the character moves accordingly. So that's the same kind of deal as when you press S and it kind of repeats. I hope that makes sense, and I've been trying to make this video for a few hours now, and I think we're finally done with all these small things. I'm going to remove these two because I don't want them to be in the GitHub upload. Let's see. And we added some scaling, and we did some other change. What more did we change? We removed the player control from the Sprite class. I think that will be enough for refactoring this time around. Coming up, we want some mouse managing and a screen manager. We might go into particle manager stuff, and we might want an entity manager. And maybe soon we can start kind of from scratch making some sort of resemblance of a game. But yeah, I'm sorry that this video became a bit long. If you don't mind long videos, please tell me in the comments below if you think they should be shortened and it's just, you know, it's just a very long video. Please shorten it down to kind of, if you think the copy pasting is bad or anything, I really just want your feedback. Please put it down there, and if you would like to, just put a thumbs up or thumbs down. And if you haven't considered it yet, please consider subscribing, and have an awesome day. Hope to see you again. See you in the next one.